So our topic for today, types of first order, first degree, ordinary differential equations. So under here, there are 9 types that we're going to discuss. So number 1, we have separable differential equation. Number 2, we have differential equations with homogeneous coefficients. Number 3, we have exact differential equations. Number 4, we have non-exact differential equations. Five, we have differential equations with exact differentials. Number 6, we have linear differential equations. 7, we have Bernoulli's differential equation. Bernoulli's. 8, differential equations solvable by simple substitution. And the last one, differential equations with linear coefficients. Okay, so these are the 9 types that we're going to have. But it doesn't mean that these are the only types of first order, first degree ordinary differential equations. It so happens only that these are the types we are interested. Okay, so when you deal with first order, first degree ordinary differential equations, there will be um, 2 types of problems with conditions that you will be encountering. So we have types of differential equations with conditions. Number 1, we have initial value problem. What do we mean by initial value problem? So initial value problem is a problem on differential equation, seeking for a particular solution subject to initial conditions, that is satisfying the same value of satisfying the conditions at the same value of the independent variables. Normally at 0, but not all the time, of course. It can be at any number. You can start with any number, and for the second condition, that same number, no? For the value of the independent variable. Examples, we have y prime is equal to 2xy squared, subject to the condition that when x is 0, the value of y is equal to 3. What does it mean? This means when x is 0, the value of y is equal to 3. Okay? If it is a first order, first degree ordinary differential equation, you are going to impose only one condition. So automatic, if there is only one condition, it is an initial value problem. Okay? What about if I have, let's say, y double prime minus 4y is equal to, let's say, e to the x, subject to the condition that when x is 0, the value of y is equal to, let's say, 0. And then there is another condition. When x is 0 again, the value of the first derivative is equal to -1. Notice that the value of the independent variable does not change, no? In the first condition and in the second condition. If there is the case, if all the conditions have the same value for the independent variable, then we call that what? First degree, initial value problem. Okay, guys? Number 2. For number 2, we have what we call boundary value problem. What do we mean by boundary value problem? It is a problem on differential equation seeking for a particular solution subject to boundary conditions. And when you say boundary conditions, that is subject to conditions at different values of the independent variable. So that's the difference at different values. If there are at least two values of the independent variable in the conditions that are not the same, it is considered boundary value problem. Example, we have y double prime minus 4y equals e to the x, subject to the condition that when x is 0, the value of y is, let's say, 0 also. And then when y prime is equal, when x is, let's say, negative 1, the value of the first derivative is positive 1. So if it is a second order ordinary differential equations, and we are going to have two conditions. If it is a first order, there is one condition. If it is a third order DE, you can impose three conditions. Okay, guys? For us to be able to solve for the arbitrary constant. So that's the use of these conditions. Will able us to determine the values of the of the arbitrary constants. So letter B, we have, let's say, y double prime plus 2y prime plus 1y is equal to 0, subject to the condition that when x is 0, the value of y is 1. When x is positive 1, the value of y is equal, for instance, to 2. So we have these two conditions. No? If this is second order, the highest condition that you can have at the first derivative. If it is a third order, the highest condition that you can impose at the second derivative, if it is third derivative. Okay, guys? Let's say I have y triple prime plus 4y prime is equal to 1 minus x squared, subject to the condition that when x is 1, the value of y is 0. When x is, let's say, 2, the value of y prime is equal to 3. And then when when y is equal to, let's say, negative, let's say 1 again, the value of y double prime is equal to 3. Look at the conditions. Although there are two identical values of x, but there are at least two that are just not the same, that are not the same, considered boundary value problem. Okay, guys? If there are no conditions imposed, what we can solve out of the given differential equation is the general solution. But if there are conditions involved, what we can solve is the particular solution. Clear, guys? So this is the first type that we're going to have. Type 1, we have separable differential equations. What is a separable differential equation? A separable differential equation is a differential equation whose all non-zero terms expressible with one type of variable only. That that means we can separate, let's say the variables are x and y, we can separate all the x with the y. Is that clear? So for instance, if I have y tangent x dx minus cosine squared x times ln y dy equals 0. So this is a separable dy, because if I'm going to divide this by, let's say, by y here, so that this will be in terms of x alone. And while this one, we have to divide by L and Y, so that this, I mean, cosine squared x, so that this will be in terms of y alone. Okay? So it means we will able to separate variables now. So because we will come up with one type of variable only involved in every term, as long as it is not 0. So multiplying by so what is our multiplier? 1 over y cosine squared x. Okay? If I multiply each side by this, the first term becomes tangent x dx over cosine squared x. Then the second term, negative ln y dy all over y, and the right side is equal to 0. Look at the first term, non-zero. It is one type of variable only. So this is non-zero again, non-zero. One type of variable is involved. Okay? As long as non-zero, one type of variable involved, so you can do that. Thus, differential equation is separable. So this involves one type of variable only. Okay? X in this case. While this one involving what? Involving y only. Is that clear, guys? So how to solve a separable D? We call this method of solution. So we have let M of xy dx plus n of xy dy equal to 0 be a separable differential equation. So assuming this is a separable, meaning we can separate variables. Notice that the coefficient of dx is in terms of x and y generally. The coefficient of dy is also in terms of x and y. So, but let us assume that this is a separable DE. So, if this is a separable DE, then I can express M of xy as what? As M, which is in terms of, let's say, A 1 of x times B sub 2 of y. So again, if I can express M such that it is a product of function of x and function of y, same thing for N of xy. If I can express N as product of function of x and function of y, I will able to separate this. Okay? So we get what? So we now have this differential equation. Our M now will become what? A sub 1 of x times B sub 2 of y dx. What about our N? Our N now becomes A sub 2 of x times B sub 1 of y dy. And this is equal to 0. Okay, guys? So from here, I can now express the first term in terms of x alone, no? By dividing by b sub 2 of y or multiplying by 1 over b sub 2 of y. Same thing here. I can multiply this by 1 over a sub 2 of x, okay? So multiply by what? Multiply by 1 over a sub 2 of x times b sub 1, b sub 2, no? B sub 2 of y. If we do this, we have what? We get what DE, guys? A sub 1 of x over a sub 2 of x, right? Dx. Second term, we have b sub 1 of y over, after multiplying by this, b sub 2 of y, no? Because a sub 2 of x is cancelled out. Multiplied by dy. The right side is 0. So meaning we have separated the variables. Okay? So variables here are separated. Variables are what? Are separated. So meaning non-zero, one type of variable only. Non-zero, one type of variable only. We can simplify this into what? Into simply a of x, because this is just function of x. Then dx, while this one, I can let b sub 1 over b sub 2 by simply b. So that is in terms of y. So dy equals 0. Get it, guys? So how to solve this DE if we have separated the variables already? So the general solution, the general solution is given by integral of this first term plus integral of the second term and the right side, because this is 0, so it is equal to c after integration. Okay, meaning it is simply a constant. Okay, guys? So here in this solution, so this is the solution. This C, the right side, is an arbitrary constant. Obtained from integration. Huh? Okay, guys? And C here can be replaced by any convenient arbitrary constant form. Let's say by C sub 1 over 2, depending on your goal in simplifying the final, the answer, no? So that will come up with the best form of solution. So ln of C sub 3, you can have that, or C sub 2, you can have e to the C sub 3, or you can have any other form as long as convenient in order for you to be able to simplify your answer. Okay, guys? So let us have a particular example. Let's say we are asked to solve the given differential equation. Solve the given differential equation. So when you say solve the given differential equation and there is no condition given, it means we have to find the general solution. Number 2. Now, can we separate variables? Let's check. Let's check. The coefficient of dx is product of function of x and function of y, no? Here, function of x is constant 1 and function of y is ln y. So we can separate variables by what? By dividing by, instead of multiplying, I want to divide. No, same thing naman. Multiplying by 1 over x, 1 over y. So it means dividing by 1 over y. Am I right, guys? Dividing by y. Okay? So we get what, guys? X e to the x squared dx plus ln y over what, guys? Over y, no? dy is equal to 0. So we have separated already the variables. So we're now ready to get the general solution. So general solution is given by integral of x e to the x squared dx plus integral of over y dy is equal to, let's have c, no? Equals a constant c. Now, but how do we evaluate this integral? So in your calculus 2, no? How do we evaluate this, guys? Anyone? By what? Exponential integration, right? By exponential integration, we have to express this in the form integral of e to the u. So this is my ux squared. My potential du is x dx. Na? While in the second integral, I can write this as ln y times dy over y. So I can apply general power formula here. My u is ln y, and this is my potential du. All we have to do is to check, no? So what is my u here, guys? X squared. What is my du? 2x dx. Is this correct du, guys? It's not, no? So for that to be du, children, I'm going to multiply this by 2, balanced by 1/2. To get what? Integral of e to the x squared times x dx originally, no? And to complete the du, so that this becomes du, I'm going to multiply it by 2, right? But I have to balance it by 1/2 outside. So how do we read this now? E to the u, du. E to the u, du. What is the integral if it is e to the u du, children? Integral of e to the u du, it is e to the u. Am I correct? Times 1/2, no? And then for the second integral, u to the n plus u to the n du. So what is our u here? Our u is ln y. What is our du? Our du is dy over y. Am I correct, guys? What is the derivative of ln y? 1 over y times dy because we want differential. So this is exactly the du. U to the n du. So by general power formula, you have u to the n plus 1 over n plus 1, then it is equal to c. No need to put plus c, because you have already a constant on the right side. Because if you put plus c in the answer, so it is just incorporated or just included in this c. Okay? Combine it here. So we have 1/2 ln o squared of y is equal to c. So I can multiply this by 2 to simplify. If you multiply this by 2, we have e to the, guys, what? E to the x squared plus ln squared y, and this is equal to, let's say, 2c. Okay, guys? I can let this 2c, to simplify this arbitrary constant, let's say by c sub 1 squared. I use c squared so that it is consistent with the evenness of its term, no? Yan. E to the x squared plus ln squared y is equal to c sub 1 squared. Kung nag-start ka sa c sub 1, your ending is, let's say, c sub c squared. Okay, guys? Now, is it correct to simply say c sub 1? It's all right. The reason why I put c sub 1 squared because for the sake of what? Evenness, no? Yan. So that it looks good. But if you put simply c sub 1, it's all right. Any question here, guys? So this is the answer. Children. Let's have number 3 if you don't have question. Number 3, is this separable, guys? Now, this is function of x. This is function of y, product. So we can separate this. What about the coefficient of dy? Can we separate variables here? Function of x times function of y. Okay, so we can separate, no? So divide by what? Divide by cotangent y. This is what we do not want in the first term, no? What about in the second term? What we do not want, this function of what? X. So that is 5 e to the 3x plus 1. Okay, guys? Yan. So, we are now going to get what? Oh, do you still remember integration, huh? So, you have to remember that. So, this is e to the 3x. What do we get now, guys? 5 e to the 3x plus 1, numerator, 3 e to the 3x. Then dx. What about the second term? We have cos secant squared y over cotangent y. Then this is multiplied by dy, no? Equals 0. Am I right, guys? Oh, have we separated the variables? Yes, no? So we now get the general solution. So how do we get the general solution? If we have already separated the variables, all we have to do is to integrate each side. Integral of 3 e to the 3x dx all over 5 e to the 3x plus 1 minus integral of cosecant squared y dy all over cotangent y. And this is equal to constant. Let's have C sub 1. Okay? I want it to be C sub 1. I want the ending to be C, to involve C. So from here, how are we going to evaluate? Let's try integral of du over u. That is leading to logarithmic na. You must be fast in identifying the integration formulas applicable. This is our u. What is du? 15, no? E to the 3x. Derivative ng e to the 3x is e to the 3x times 3 times 5. So 15. Then this is 0. So dx simply multiplied by dx here. What about the u here? What do you think, guys? So ang u natin, cotangent y. Let's try the du. If we get the numerator as the du, negative cosecant squared y dy. Actually, you have already the hint for the derivative of the chosen u. So most probably, everything is there, except perhaps for the constant coefficient na. Okay, guys? So we have cosecant squared y, then dy. So possible na, no? So getting here, we need 15, no? I will put 3 out, and I will put 15 balanced by 1 over 15. Or I just put what? Pwede ring multiplied by 5, balanced by 1 over 5. So that it is 15. Am I correct, children? Guys? Children? I multiply by 5 because I need 15. What did I multiply? What did I multiply to 3? 5, no? Balance outside by 3. So here, denominator. Yan. Okay, so this is du over u. Integral of du over u. Let's evaluate that later. So ready now for integration. What about this one? What I need is negative, right? Negative cosecant squared y dy, and then here put negative all over cotangent y. Okay, guys? Let's now evaluate. What's the integral of the first term? So that is 1/5 du over u, integral of du over u, ln u. So we have 5 e to the 3x plus 1, no? No need for absolute value here. Why? Because 5 e to the 3x is never negative. So absolute value is immaterial here. Plus du over u. What is the integral of du over u? Ln of absolute value of cotangent y. We need absolute value here because cotangent y can be negative, can be positive, no? Depending on the value of y. Okay, guys? So I can multiply this by what? By 5, no? So by the way, it is equal to C sub 1, right? So this is 5, C sub, it is C sub 1 for the meantime. Multiply by what? 5. So getting what, guys? Ln of 5 e to the 3x plus 1 here plus 5 ln of absolute value of cotangent y is equal to 5c1. I can combine these two logarithms. What I am doing is I'm just trying to simplify the answer. Actually, this is already the answer, no? I'm just trying to what? Okay, guys? So we have ln in just one what? In just one plus 1, just one logarithm. Is it product or quotient, guys? product, no? Am I right, children? Guys, 5 e to the 3x plus 1 times the absolute value of cotangent y raised to what? This coefficient becomes exponent of cotangent. Okay, guys? Children, I can still simplify this by making each side exponent of e. So it is now 5 e to the 3x plus 1 absolute value of cotangent to the fifth y is equal to e to the 5c1. So I can remove the absolute value on the left side by having only 5 e to the 3x plus 1 times cotangent to the fifth y, and then it is equal to plus or minus the right side, no? 5 to the c e to the 5c1. So I can simplify this. So finally, we get 5 e to the 3x plus 1 multiplied by cotangent to the fifth y is equal to, let's say, c. Okay, that's it. Okay? So for simplicity, so I can let this right-hand side by simplicity because that is constant. So take note, you can only let by a simple constant those coefficient or that coefficient, even complicated, as long as constant, not involving variable. So if there is, let's say, x here, you cannot include the x to be part of the constant. So this is the only part that you can let by c. And if there is a x here, you have cx. Guys, do you have any question with that, guys? Okay, none. Number 4. What about number 4? What do you think about this problem, guys? Guys, what do you think about this? What is our multiplier or divisor? Divide by what? Here, divide by secant of pi y, no? What about here? We divide by 1 plus 16x to the fourth, right, guys? So we get what, guys? Guys, 8x. What is the denominator?
Sir, yung quantity 1 plus 16x
So
raised to
all over 8x dx all over 1 plus 16x to the fourth, right? Minus pi sine squared pi y dy all over and over secant pi y, no? Okay, children? Yan. So, and the right side is 0. So, we have already separated the variables. So, we cannot get the general solution. As long as you are good in algebra, and then integration also, you can easily get the simplified general solution. So the general solution is given by this integral of 8x dx over 1 plus 16x to the fourth minus integral of pi sine squared pi y quantity dy all over secant of pi y, no? Okay, guys? Equals, let's have it C. So from here, C sub 1. So that we have C at the end. What do you think here? what integration formula is applicable? What do you think, guys? First integral. Guys, guys, I can apply what? Integration leading to inverse trig, no? So I can take this as my a squared, and my u squared is 16x to the fourth. So what is my u? 4x squared. Am I correct, guys? What is the du? 8x dx, which is the numerator. So this is du over a squared plus u squared. So exact already, no? What about here? I have to bring this up, no? So I think my u here is sine, no? And the du is cosine after bringing it up. So this first term here is what? It is equal to 1 over a, 1 over 1, arctangent of u over a. But what is my u? 4x squared. 4x squared. My a is 1, no? Minus, I can put this as what? Sine squared pi y times pi. What is 1 over secant? That is cosine, no? Then its argument is pi y I mean. Then dy equals c sub 1. So copy. What is my u here? In the second, in this integral, in this line, my u here is sine pi y, no? By power formula, general power formula, n is equal to 2. Our du is, what is the derivative of sine? Cosine. Then copy pi y. What is the derivative of pi y? Pi. Then multiply by dy because you want it differential. So this is u to the n du. U to the n du. Power formula. So getting tangent inverse of 4x squared, then minus, what about here? Again, u to the n du. U to the n plus 1 all over n plus 1. Right side, c sub 1. Okay? Let's simplify by multiplying by 3. So this is 3 now. And then we have minus sine cubed of pi y is equal to 3c1. But I can let this by what, guys? Guys, I can simplify that arbitrary into what? Any suggestion, guys? Guys, by c, no? And for simplicity. Again, where 3c sub 1, we let it by c. So we have this. A question, children? Guys.
Wala naman po.
Sir,
Okay.
sir, may ano
Yes.
po ba? May way po ba if tama yung ginagawa? Or,
You should check your integration, or from this answer you eliminate arbitrary constant until you get the given. Diba it's the
okay, sir.
opposite? Remember what we did
Okay.
before? We were determining differential equation from the given general solution. This time we're given the DE. What's the general solution? Is this. So you can check, eliminate the arbitrary, and then you must get the given. Okay?
Okay po, sir. Thank you
Okay.
po.
Thank you. In case you have questions, don't hesitate to ask questions, ha? Because I want you to have nice grades, no? Yan. Para maganda yung transcript. What about this, guys? Parang paras lang yata ito. Na? Am I right? Paras lang siya, na? Okay, we're done with this. What about this? This is number 5. The given is in derivative form. No? This is differential equation in derivative form. First order, first degree. Question is, can we separate variables and express this in differential form? Yes. Because y prime means what, guys? dy over dx. Am I correct, children? Then we have y minus 1 all over 2x, x plus 1. So to separate variables, I have to divide by what, guys? Divide by y minus 1, no? And then multiply by dx, right? So I will get now dy over y minus 1. Am I right? And then 9x plus 5 all over 2x, x plus 1 multiplied by dx. So we have separated the variables already. No need to transpose or no need to put this right side on the left side, meaning no need to add its opposite so that opposite of this so that this will disappear from the right side and then equal to 0. No need. So as long as separated the variables, it's all right, whether on the left side or on the right side. Okay, guys? So general solution now. General solution. We have integral of dy over y minus 1 minus integral of 9x plus 5 2x x plus 1 is equal to c sub equals, no? Yeah. No need for sim for the meantime because there is no 0 on the right side, no? It is this equal to this. So we are going to put the c later just on the right side or on the left. But normally we write it on the right. So how do we evaluate the first term, guys? Ito okay na, no? You can easily evaluate this. Integral du over u. Problem is the right side. Right side, we can apply what, guys? Any suggestion, guys? We can apply what here? Guys, partial fraction, no? Integration by partial fractions. Is that clear, children? So let 9x plus 5 all over 2x, x plus 1. Yan. By the way, yung 2, for simplicity, lagay ko na lang dito, ha? Dito na lang. Multiply by 2 so that there is no 2 here for convenience. Okay, guys? Yan. So yung 2, I just put it here. Originally, it's here, but I can put this out. So this is equal to, guys, to what? By partial fraction, a over x plus, guys, b over, they are now quiet. Are this strange to you, guys? Let's multiply by, actually, no need to multiply, no? There is a technique so that you can easily solve for the values of arbitrary constant. To solve for a, think of value of x that will make it 0 when x is 0. And then remove the factor in the denominator, making it, that is becoming 0, no? Because I'm trying to have 0 for x. That is a technique, no? So 9 times 0 plus 5 all over, I will remove x. 0 plus 1. So that's the value of A. Okay, guys? So that you can easily get the value of A fast. To solve for B, for what value of X it will be 0 when X is negative 1. So 9 times negative 1 plus 5 all over negative 1. No? You remove the X plus 1 this time. You substitute to X negative 1. This is what? Negative 4 over negative 1, positive 4. Am I right, children? Guys. So,
Yes po, sir.
we now have, what is the integral of the per? Let's copy first. Integral of dy over y minus 1. And that is equal to integral of, what is now 9x plus 5 all over xx plus 1, guys? Guys, what is that equal to? A, what is my A? 5 dx over x plus
5 over.
integral of b. What is b? 4. Then dx over x plus 1. Okay? That is my integral of 9x plus 5 all over guys. Get it, guys? Guys. So we have 2. Oh, what is the integral? 2 ln of absolute value of y minus 1. 2 times ln of absolute value of y minus 1. Ito. 5 ln of what? Absolute value of x plus 4 ln of absolute value of x plus 1. Okay? Di ba du over u? Yung 4 i-out ko, yung 5 i-out. So, I have to add c ha. Yan. Now, plus c. Okay, guys? Yan. Then, for simplicity, if you want, c sub 1. Para ang ending natin later c. I can combine all the logarithms. Di ba ito magiging exponent? ln of what? Y minus 1. Quantity squared. Ito, pag lumipat sa kaliwa, negative. Mapupunta siya sa denominator. Tama ba, guys? X to the
Yes po,
fifth.
sir.
At ito naman, mapupunta sa denominator. Then, no? Kasi nasa negative din siya eh. X plus 1 raised to 4. And then, absolute value nung, actually, ang may absolute value lang dito yung x to the fifth. Kasi puro even naman to. Pero kung gusto niyo, pwede namang the whole thing. Equals c sub 1. O make both sides exponent of e. E to the, then e to the. So we have y minus 1 quantity squared all over, meaning change to exponential form. X to the fifth, x plus 1 raised to 4. And this is equal to e to the c1. Okay? Then, I can let this by simply what? A constant, let's say. By the way, may absolute value pa rito, no? So, pag inalis ko yung absolute value, plus or minus on the other side. Equals plus or minus e to the c sub 1. But I can let e to the c sub 1 plus or minus by what, guys? By simply c. If I let plus or minus e to the c sub 1 by simply c, so we now get what? Y minus 1 quantity squared is equal to, what is my plus or minus e to the c1? This is just constant. So c times what? X to the fifth, x plus 1 raised to 4. Okay, children? Oh, that's it. Question, children? Guys?
Sir, kailan
Yes.
po gumagamit ng ano, sir, yung power factor po, yung doon sa left side, yung ginawa kinuha niyo po yung may A over X po. Kailan po siya ginagamit, sir?
Which one?
Yung nasa left side po, sir, yung A over X plus B over X plus 1 po.
Itong A. Pag we have rational function na you will not able, that you can evaluate by what? You can't evaluate by basic integration formula. We apply integration by partial fraction.
Okay po, sir. Pag wala po siya, ano, sir, yung parang hindi po maggamitan ng iba't ibang
Oo,
formula,
you
yan po
can't
yung
you
gagamitin
can't
niya.
apply d over u or inverse trig. You can review integration in my YouTube. You just look for calculus 2. You can review their integrations. Okay, guys?
Okay po, sir. Okay po.
You look
Thank you,
for the
sir.
partial fraction topic there. It will help you. Okay na, guys? Well, let's have...
Yes po, sir. Thank you po.
Okay, let's have this. So this time, there is condition, no? What if you have a problem with condition? So, solve the given initial value problem. Initial value problem. Okay? Okay, guys? Okay, so why is it initial value problem, guys? Guys, why is it initial value problem? Again, because there is a condition. If it is a first order, first degree, automatic there is only one condition, and that is an initial value problem. What does this mean? When x is what? What does this mean again, guys? Guys, what does this mean? When x is what? When x is e cubed, the value of y is pi over 2. It's not y times, it is y of e cubed equals pi over 2. Okay? Okay, guys?
Yes po, sir.
Wait a minute. Okay. So let's have number this, no? So to solve this initial value problem, we need to get the general solution first. So same procedure, no? 8 ln x times what? Secant y dy minus 5x sine squared y dy is equal to 0. We need to divide by what, guys? Here, we need to divide by secant, right? What about here? We need to divide by x, no? So, we get what? 8 L, no, ln, sorry, this is the, I got the wrong cap. This is dx. So, 8 ln x dx, then minus 5. What happens here? Ano yung magiging denominator nito, children? Yung unang term. Guys. 8 ln x
Then dx
over,
x.
what about the second term? Sine squared y dy over secant, right? Equals 0. Okay, so what's the general solution?
Sir, nawala po yung 5.
Alin ang nawala? Yung 5, sorry. Okay.
Okay po.
Thank you. What is the general solution? We integrate, no? Actually, start na to ng general solution. But this is not what? Not yet in simplest form, no? Because there is still integral sign. Over x minus integral of, what about here? 5 sine squared y dy over secant y equals c constant, no? Let's have C1. Okay? So, this can be written 8 ln of integral, no? Integral of ln x times dx over x. This is a direct one, no? U to the n du. Using what? Using general power formula, u to the n du. What about this one? 5, I can write this 5 integral of sine squared y times secant 1 over secant is cosine, no? Which is power formula also. Am I right? U to the n du. U to the n du. So what is my u here? Ln x. What is my du? Dx over x. So this is ln of what? A ln of A ln squared x u to the n plus 1 over n plus 1. Second term, minus 5 times u to the n plus 1 sine cube y over 3 equals c sub 1. Again, general power formula, ha? U to the n du. So this is for ln squared x minus 5 over 3, then sine cubed y equals c sub 1. Let's multiply by 3. Multiplying by 3 to get 4 times 3 is 12, no? Ln squared x minus 5 sine cube y equals 3c1. Let 3c1 be equal to what, guys? Simply 3. So what's the general solution? 12 ln squared x minus 5 sine cubed y equals c. I sorry, wait, that not 3. This is c. So I now have a general solution. How to find for the value of c? Because we want particular solution because this is an initial value problem. When you say initial value problem, looking for a particular solution from the given what? This differential equation. So subject to the initial condition, no? That is having one value only for the, or same value for the independent variable. So for the value of c, let's have color to emphasize. For the value of c, what are we going to substitute, guys? So we have 12. At the point at x equals e cubed, pi of, what is y? Pi over 2. Twelve ln squared. What is x?
E cube po.
E to the third, no? Minus 5 sine of, what is y?
Pi over 2.
Sine cube pi over 3, 2, no? Ito yung y. Pi over 2 ba? No? Equals
Yes, pi
c.
over 2.
O, ano yung 12 ln squared e cubed? Ang ln squared means ln e cubed raised to 2. Okay? Minus, ang sine pi over 2 is 1. So 5 times 1 raised to 3 equals c. Ano yung value ng ln e cubed, guys? 3 squared because naka-square siya. Minus 5 equals c. O ano ang value ng c, guys? Guys, anong value ng C? Guys. Guys. 100?
103 po.
3. Finally, we have now the particular solution. This is what we are looking for, meaning the solution to this initial value problem. What is the particular solution? Substitute the value of C to the general solution here. So 12 ln cubed x minus 5 sine cubed y, ln squared, no? ln squared x minus 5 sine cubed y equals C. What is C? 103. Oh, that's it. Clear, guys? Let's have the second one. So we don't stop to the general solution, no? So first, what are we going to do here, guys? Solve for the general solution, no? Let's copy the given. So we separate variables. How do we separate variables? So by this time, you can do it mentally, no? What factors here I do not want for the coefficient of dz? Because this is dz, I want to get rid of w, ln w minus 4, right? So divide by w, ln w minus 4. What else? What about here? By cosine z, no? Because this is dw, we want it in terms of w. Getting w, I cosecant z dz, guys, dz over cosine z, right? Second term, dw over w ln w minus 4. That is equal to 0. So we have separated the variables already. So what's the general solution? Integral of cosecant z dz all over cosine z plus, what about this, guys? Actually, yung w, we need to put it up para maging differential niya nung denominator na ang iwan natin in the denominator, let's leave this, ln w minus 4. Okay, guys? Get it, guys? Equals C. Let's have C1. How do we evaluate the first term? Any suggestion, children? Guys, multiply both the numerator and denominator by what, guys? Guys, ano yung pang-multiply natin para it will become ready for integration? Children. Yung cosine z, retain dyan, tsaka ito, no? Ang multiplier natin is what? Multiply natin siya ng cosecant over cosecant. Yan, by inspection. Dapat nararamdaman nyo, you can feel what to do so that you will come up with the better integration technique or formula to be used. Plus, this is du over u. So this is ln of what? ln of u. But what is our u? ln w minus 4. Look at this. This is u. I mean the denominator. What is the du of the denominator? Anong derivative ng ln w? 1 over w. In terms of differential, multiplied by dw. So 1 over W, dW. So du over u, the ln u, ang u natin, ln w minus 4. What about the second, this integral, remaining integral? Guys. So cosecant times cosecant, that is what, guys?
Cosecant squared.
Cosecant squared z. What about the denominator? What is cosecant? Pag na-multiply sa cosine, that is cosine times what? Times 1 over sine. Am I right? Cosine z times cosecant. But what is cosecant? 1 over sine. Am I correct, children? What is cosine over sine? Guys.
Cotangent.
Cotangent. Is cotangent related to cosecant squared? Related na? Because that's its derivative. Just missing the negative na? Am I right, guys? So we now have put negative. I will put negative. Balanced by negative outside, no? Okay, children? Equals C sub 1. We can now integrate this. Negative du over u, ln of, negative ln of, absolute value of cotangent u, I mean cotangent z, plus ln of w minus 4. I can combine these two logarithms. Actually, this is already the answer, but not in simplified form, no? So, starting here is the general solution. But we are trying to remove the integral sign and then simplify, no? ln of w minus 4 over cotangent. Am I right? Because negative, di ba? Negative na you put in the denominator, no? You can write that as a single logarithm. In exponential form, okay? E to the C1. Remove the absolute value. We get what? ln of w minus 4 all over cotangent z equals plus or minus e to the C1. Okay? Or for simplicity, what is that, guys? Children. Guys.
C, sir.
C. Okay? Let this be C. Now, we know the condition, no? For the value of C. What's the value of C, guys? For C, anong gagamitin natin? When W is equal to e to the 8, what's the value of Z, guys?
Pi.
Pi over 4. We can solve now for C, no? So ln W, that is ln of e to the 8, minus 4 over. By the way, yung 4 dito wala sa ln, ha? Cotangent pi over 4. What is cotangent pi over 4, children? Guys, what is cotangent pi over 4? 1, no?
1.
What is ln e to the 8? Simply 8. What's the value of C? Guys.
4, sir.
4.
The value of C is 4.
4.
So we can now write that particular solution. Guys, what's the particular solution? Let me write it here. I think we still have space. This is the next. So particular solution is given by, so this is the final answer. ln W minus 4 and then cotangent C times C. So that is 4 cotangent Z because our C is 4 times cotangent z. Okay, guys? Oh, that's it. Oh, any question, children? Guys?
Wala po, sir.
Number 3. What about this? Given this, with the condition that when x is 0, y is 0. Okay? We can separate variables also here. But not all DEs can have separate variables that can be separated, huh? Once we have another type, so you have two types by that time to consider. You should know how to identify the different types of DE. So solve for the general solution. To solve, first we eliminate, we separate variables, no? So alin ang aalisin natin dito? Yung cosecant squared y, no? So dito sa kabila, mapupunta sa ilalim nito, we'll go here square root of x minus sine y. What will be in the denominator, guys? Am I correct? So general solution, integral of this. I can write this e to the square root of x times, because my potential differential is dx over the square root of x by taking e to the u, possible to be the du. Here, I can bring this up to get sine squared times sine, it is sine cubed. Let's have it C1. Okay? What is my u here, guys? Square root of x, e to the u. What is my du, children? Dx over 2 square root of x. Still remember how to differentiate square root, guys? You can have x to the 1/2, x to the negative 1/2 if you want. Or directly, square root of x, the derivative is 1 over 2 square root of x. This is by what? By trigonometric transformation. Do you still remember that, guys? Guys, do you still remember that? Or you have forgotten already everything? Guys. Originally, there is no 2 here, no? In the denominator. So I will put 2 balanced by, so 1/2. I will put 2 outside, no? Balanced by 2 because I put 1/2 inside. So e to the u du. What's the integral of e to the u du? E to the u. Okay, children? But what about the second term? Second integral. That can be evaluated by integration by transformation, trigonometric transformation. So it is sine squared times sine. Sine squared means cos 1 minus cosine squared. This is sine squared times the remaining sine. Then separate by distributive property. No? But the first integral here is equal to 2, then e to the u. Integral of e to the u du times 2. E to the u. Okay? Times 2. Minus, let's now have integral of sine y dy. This is basic integration. Plus, negative, negative, positive now. Integral of what? Cosine squared y times sine y dy. Okay, children? Guys, what is the right side? C1. But if my u here is cosine, what is my du, children? Negative sine, no? Negative sine y dy. I put negative, I balanced by negative. So we got 2 e to the square root of x minus integral ng sine is negative cosine. So positive now. I will put negative balanced by negative. So negative, no? Again, guys, I need negative, ha? So balance by negative. So negative. Then u to the n plus 1 u to the n du after putting negative. Balanced by negative. So, over 3 is equal to C. Okay, children? Guys, multiply by 3. 6e to the square root of x plus 3 cosine y. Guys, minus cosine cube. Y equals 3c1. 3c1. Let 3c1 be equal to what?
Equal to C.
C. Yeah. For simplicity. So we get 6e to the square root of x plus 3. Is my integration correct, guys? Let's now solve for C by applying the condition. Ano yung condition natin? X is 0, y is 0, right? We have 6e to the square root of 0 plus 3 cosine 0 minus cosine cube 0 equals C. What is cosine 0, children? Guys, 1, no? What is the value of C finally? What is C, guys? 6, 9, is it 8, children? Boys? 8, no? Okay na, guys? What's now the particular solution? Let's make it colored nga, the answer. So the answer is 6e square root of x plus 3 cosine y. Don't get confused with the derivative and integral. The integral of sine is negative. The derivative of sine is positive cosine. Cosine cube y is equal to 8. That's it, guys. A question? Children? No question? Guys?